Hey everyone, tonight we're drifting nearly 300 million miles from home, deep into the asteroid belt where silence weighs heavier than gravity ever could, and the sun shrinks to just another bright star among countless others. You're about to spend one ordinary shift with an asteroid miner working the extraction fields between Mars and Jupiter. Ordinary meaning bone-deep isolation, rock dust that clings to everything, and the constant hum of life support systems that stand between you and the absolute void. Fair warning, you probably won't survive this schedule with your romantic notions of space intact. Before we float any further, take a moment to like this video and subscribe, but only if you enjoy what I do here. While you're at it, drop your city and local time in the comments. It's always fascinating to see night owls from Sydney to Sao Paulo checking in. Now dim the lights, maybe adjust your headphones, and let's ease into tonight's journey together into the cold mathematics of asteroid extraction, where humanity's resource hunger meets the raw economics of deep space. The alarm pierces through your sleep like a drill bit through carbonaceous regolith. Not the gentle chime of an Earth morning, but a persistent electronic warble calculated by efficiency experts back on Earth to jar you into consciousness with minimum psychological damage. Your sleeping bag restraints have kept you anchored to the bunk's padded wall throughout the station's artificial night cycle, but your body still feels that peculiar weightless drift, that sensation of falling that never quite resolves into landing. You blink against the darkness, watching the habitat module's dim emergency lights cast their green glow across curved metal walls. The station, officially designated Mining Platform 7, but known to its 12 permanent inhabitants simply as Prospector's Haven, rotates slowly to provide 0.3 Earth gravity, just enough to keep bones from turning to chalk and muscles from withering into useless strings, but not enough to feel truly grounded. Everything floats with a lazy determination, including the water droplets that escaped yesterday's shower and now orbit near the ceiling like tiny satellites. Your hand finds the alarm panel, silencing the noise. Silence rushes back, but it's not really silent, never truly silent out here. The ventilation system whispers its constant song, circulating the same recycled air you've been breathing for 3 months. Somewhere deeper in the habitat, the water reclamation system gurgles and hisses as it processes yesterday's waste into tomorrow's drinking water. The solar panel servos click and whir as they track the distant sun, that small, bright disk that looks almost apologetic from this distance, as though embarrassed it can't provide more warmth. You unzip the sleeping bag, a motion that requires more care than it would on Earth. Everything moves differently. At 0.3 gravity, release something carelessly and it'll drift for seconds before lazily settling, giving you plenty of time to watch your mistake float away. The bag peels away from your body, taking with it the cocoon of warmth you've cultivated through 6 hours of fitful sleep. The habitat temperature holds steady at 68 degrees Fahrenheit, but somehow space cold seeps through the insulation, through the metal walls, into your bones. The sleeping quarters measure 8 feet by 6, barely larger than a closet, but in microgravity, floor space matters less than volume. Storage nets bulge from every wall, packed with personal items that pass the strict weight restrictions. 3 family photos in waterproof laminate, a thumb drive containing 10,000 songs, a small stuffed elephant from your daughter that's traveled farther from Earth than most humans will ever venture. These fragments of home, carefully rationed, are what stand between you and the crushing vastness outside. You push off from the bunk, floating in the lazy way of low gravity toward the sanitation module. The mirror there shows someone you're still getting used to. 3 months of 0.3 gravity has elongated your face slightly, pulled fluid upward from your legs into your torso and head, giving you that characteristic puffy appearance that all long-duration miners develop. Your eyes look tired, the white slightly reddened from the station's dry air. Your hair, grown longer than regulation because who's checking out here, floats in a way that would be comical if you had the energy to laugh. The sanitation routine is a carefully choreographed dance that took weeks to master. The shower is really just a humid enclosed box where you spray yourself with water that immediately tries to escape as floating spheres, and you've got exactly 2 liters for the whole process, recycled from yesterday's waste and purified through filters that perform minor miracles. The soap is waterless, spreading across skin with the texture of thick gel. You work it into your hair, across your body, knowing that every molecule of water you use today will cycle through the reclamation system and come back as tomorrow's coffee. The water vacuum attachment sucks up the moisture, pulling it through filters and into storage tanks. Nothing gets wasted this far from home. Every drop, every molecule, every bit of organic matter goes back into the system. The irony isn't lost on you that you're mining asteroids for water ice while rationing every milliliter like liquid gold. But the water you mine goes into fuel production, broken down into hydrogen and oxygen to power the processing facility and the shuttlecraft. The water you drink is your personal allocation, recycled endlessly, the same molecules passing through your body again and again. Shaving requires even more care. The foam dispenser hisses out a small blob that clings to your face through surface tension and the weak gravity. The razor glides across your skin, scraping away 3 days of growth. The debris vacuum catches the shaved hair immediately, preventing it from contaminating the air filters. Did you know that one of the earliest space stations had to be evacuated because floating hair particles clogged the carbon dioxide scrubbers? The engineers who designed Prospector's Haven learned from every mistake written in the margins of space station history. Dressed in your station jumpsuit, a one-piece garment of flame-resistant material covered in pockets and utility loops, you float walk toward the galley module. The corridor connecting the modules is just wide enough for 2 people to pass if they're friendly. Hand grips line the walls every 18 inches, providing purchase in emergencies. The metal walls display mission patches from previous crews, small declarations of human presence in this vast metallic tube spinning through the void. The galley module serves as the social heart of Prospector's Haven. 6 crew members are already there, floating around the table that's magnetized to hold food trays in place. The smell hits you first. Coffee, the real stuff, sent up on the last supply run 3 weeks ago. They allot each crew member 2 real coffee packets per week. The rest is synthetic, a chemical approximation that tastes like someone described coffee to a computer that had never experienced taste. Your breakfast comes in vacuum-sealed pouches, arranged in a meal tray with gentle Velcro strips to prevent drift. Scrambled eggs, or rather, a protein composite engineered to approximate eggs. A wheat tortilla, which works better than bread in low gravity since it doesn't produce floating crumbs that could clog equipment or invade someone's eye. A fruit cup of preserved peaches swimming in heavy syrup. An electrolyte drink that tastes like slightly sweet plastic. This is the fuel that will power your 12-hour shift in the extraction fields. You eat slowly, methodically, while the morning briefing plays on the wall screen. The operations manager on Earth, speaking with the crisp certainty of someone who won't spend today anchored to a spinning rock 300 million miles from home, outlines the daily targets. Platform 7 is responsible for processing 17 tons of asteroid material per Earth day, a quota that sounds reasonable until you factor in equipment failures, unexpected asteroid composition, and the simple exhausting reality of working in a pressure suit. Your assignment today focuses on asteroid 2043KX, designated as a target-rich C-type body measuring roughly 200 meters across. Spectroscopic analysis suggests significant water ice deposits beneath the surface layer, bound up with carbon compounds and silicate minerals. If the analysis is correct, and if you can extract and process enough ice, the hydrogen and oxygen derived from splitting those water molecules will justify the operation's cost. Every mission planner in the solar system runs the same brutal calculation. Does the value of extracted resources exceed the cost of getting humans out here to extract them? The crew chat flows around you like water around a stone. Elena Vasquez, the geologist specializing in asteroid composition, talks about yesterday's core sample from a different asteroid, how the mineral distribution suggests it came from the outer edge of the belt. maybe even originally from beyond Jupiter before some ancient collision sent it spinning inward. Marcus Chen, one of the shuttle pilots, jokes about the supply manifest for next month, whether they'll finally send the good coffee or keep rationing out the synthetic disappointment. You half listen, half watch the briefing, half exist in that particular state of consciousness that develops during long-duration missions. Part of you is present, eating breakfast, responding to questions. Part of you is already running through the day's procedures, mentally checking equipment and reviewing extraction protocols. And part of you, the part you don't acknowledge in the daily psychological assessments, is 300 million miles away on Earth, wondering what your family is doing, whether your daughter remembers your face or just the photo she keeps by her bed. The psychological toll of isolation. Every mining operation handbook addresses it with the bland certainty of bureaucratic writing. Crew members will experience periods of melancholy, particularly during Earth out-of-view phases when the pale blue dot shrinks to insignificance. Recommended countermeasures include regular exercise, social interaction, meaningful work, and scheduled video calls with family. What they don't mention is how the meaningful work becomes routine, how social interaction happens with the same 12 faces day after day until you know everyone's stories by heart, how exercise is just another item checked off the daily requirement list. The video calls. Twice a week, you're allocated 30 minutes of bandwidth to talk with your family. Except it's not really talking, not with the communication delay. Radio waves travel at the speed of light, which sounds fast until you're waiting 22 minutes for your daughter's response to, "How was school today?" You send messages, careful narratives about your day with all the fear and exhaustion edited out, and 22 minutes later you receive messages back, carefully composed responses that feel like letters from a parallel universe. Real conversation, the spontaneous back and forth that makes human connection that died about 100 million miles ago. Breakfast ends with the ritual of waste disposal. Every scrap goes into the composting recycler, a complex system that breaks down organic matter and feeds it into the station's small hydroponics bay. The bay produces fresh vegetables, mostly lettuce and herbs, barely enough to supplement the packaged meals, but psychologically invaluable. There's something about eating a tomato you watched grow from a seedling, something that ties you back to Earth's patient growing seasons and reminds you that life persists even here, spinning through the void inside a metal shell. You rinse your utensils in the minimal water sink, watching the liquid cling to the metal in surface tension blobs before the vacuum drain sucks it away. Then it's time for the daily medical check, a requirement that can't be skipped. The medical station, really just a curtained alcove with basic diagnostic equipment, monitors every crew member's vital signs. You press your finger against the blood oxygen sensor, watching the small screen calculate your readings: heart rate, blood pressure, bone density scan, cognitive response test. The data uploads automatically to the medical team on Earth, adding your numbers to the vast database of long-duration space health statistics. Everything reads within acceptable parameters, which is good because the nearest hospital is approximately 300 million miles and 8 months away. The medical supplies aboard Prospector's Haven can handle minor injuries, infections, basic dental problems, and some emergency surgical procedures. But anything serious means medical evacuation, which means mission termination for at least one crew member who'll travel back on the supply shuttle. No one wants to be that person, the one whose body betrayed the mission. With breakfast and medical checks complete, you float toward the equipment bay where your pressure suit waits. The suit is a marvel of engineering, a wearable spacecraft that will keep you alive in the absolute hostile environment outside 23 layers of material, each serving specific purposes: thermal insulation, micrometeorite protection, radiation shielding, pressure containment, mobility joints, communications equipment, emergency oxygen reserves, waste management systems, and an intricate web of sensors monitoring every vital sign. You inspect the suit with the paranoid thoroughness that keeps miners alive. The helmet's faceplate, checking for any microcracks that could propagate under pressure and expose your face to vacuum. The gloves, flexing each finger joint, testing the heater elements that prevent frostbite in your extremities. The primary oxygen tanks, reading 97% full, good for 8 hours of normal activity or 4 hours of heavy exertion. The backup oxygen, 60% full, enough for 2 hours of emergency breathing. The suit's primary seal, examining the rubber gasket for any degradation or contamination. The suit diagnostics panel runs through automated checks while you trace power lines and communication cables with experienced fingers. Green lights appear one by one. Thermal regulation operational, carbon dioxide scrubbers active, communication systems nominal, emergency beacon functional, suit integrity at 100%. Each green light is a small mercy, one less thing that might kill you today. Suiting up is a 20-minute process that requires help. You can't reach the back seals alone, can't verify that every connection locked properly. Your suit technician today is Yuki Tanaka, a quiet woman who treats pressure suits with the reverence usually reserved for religious artifacts. She triple checks every seal, every connection, running her gloved hands over the suit's surface like a doctor examining a patient. Her diligence has saved 3 lives in the 2 years she's been on Platform 7, finding problems that automated diagnostics missed. The suit pressurizes with a hiss that you feel more than hear, the fabric stiffening around you, transforming from clothing into a rigid shell. You flex your fingers in the gloves, testing the resistance, getting a feel for how much force you'll need to grip tools today. The suit adds bulk and reduces dexterity, turning every simple task into a carefully considered action. Dropping a tool in microgravity while in a pressure suit means watching it drift away into the void, becoming just another piece of space debris in humanity's growing cloud of orbiting junk. The helmet locks on with a solid clunk that reverberates through your entire suit. Sound transmission changes immediately. The outside world becomes muffled, distant, filtered through the suit's external microphones and processed by the communication system. You can hear your own breathing now, amplified by the helmet's confined space. Every exhale fogs the faceplate slightly until the dehumidification system kicks in. Every inhale carries the suit's characteristic smell, a mixture of plastic, recycled air, and the faint tang of clean sweat from previous shifts. Final systems check. You recite the litany that's been drilled into your muscle memory through 1,000 repetitions. Oxygen pressure nominal, carbon dioxide scrubbers active, thermal regulation online, communications check. Your voice crackles through the radio, bouncing to the communications relay and back to confirm the system works. The voice of mission control, actually just another crew member monitoring operations from inside the habitat, confirms your readings. Copy that. Your go for EVA. Proceed to airlock when ready. The airlock is a small cylindrical chamber that stands between the habitat's breathable atmosphere and the absolute vacuum outside. You cycle through alone, standing in the cramped space while the outer door remains sealed. The air evacuation process takes 3 minutes, time spent listening to your own breathing and watching the pressure gauge drop towards 0. The habitat's air, precious and recycled, gets pumped back into storage tanks rather than vented into space. Nothing gets wasted this far from home. At 0 pressure, the outer door unseals with silent deliberation. Silent because there's no air to carry sound waves, no medium for vibration to propagate through. The door simply moves, revealing the universe beyond. The asteroid belt stretches in every direction, countless rocky bodies tumbling through space in their eternal orbits around the distant sun. From here, the belt looks sparse, nothing like the dense debris field portrayed in entertainment media. The asteroids are scattered across millions of cubic miles, separated by distances that make them invisible neighbors. The sun hangs small and bright against the absolute black, roughly 3 times smaller than it appears from Earth, but still overwhelmingly the brightest object in the sky. It provides enough light to work by, but not enough warmth to feel through the suit's layers. The temperature outside hovers around -100 degrees Fahrenheit in sunlight, dropping to -250 in shadow. Without atmosphere to moderate extremes, temperature becomes a binary condition, directly illuminated or free solid darkness. You engage the maneuvering pack, a simplified propulsion system attached to your suit's back. Small jets of compressed nitrogen provide thrust, allowing controlled movement in 3 dimensions. The first thrust always feels wrong, your inner ear screaming that you should fall while your training insists that down is a meaningless concept out here. You drift away from the platform, watching it shrink against the star field, becoming just another constructed object spinning through the void. The work shuttle waits 40 meters from the platform, anchored to a docking spine that bristles with equipment pods and supply canisters. The shuttle is purely functional, no streamlined aesthetics needed where there's no atmosphere to move through. It's essentially a powered frame with multiple tool attachments, storage compartments, and a minimal crew compartment barely larger than a phone booth. 2 pilots and 4 miners can fit inside, pressed together like canned fish, breathing recycled air and trying not to think about the millimeters of metal between their bodies and hard vacuum. You lock your boots to the shuttle's outer hull, engaging the electromagnetic soles that provide purchase on ferrous surfaces. The slight pull of magnetic attraction is oddly comforting, a tiny simulation of weight that your body craves after months of low gravity. The other miners are already aboard, Chen and Vasquez, along with 2 others whose shift began an hour before yours. The shuttle pilot, Marcus Chen, runs through the pre-flight check with practiced efficiency. Thrusters operational, guidance system calibrated, communications relay locked onto Platform 7's beacon. The journey to Asteroid 2043KX will take approximately 38 minutes, crossing 15 miles of space at the shuttle's efficient but unhurried pace. Fuel economy matters more than speed out here. Every droplet of hydrogen-oxygen propellant was either brought from Earth at devastating cost or laboriously extracted and processed from previous mining operations. The shuttle disengages from the platform with barely perceptible motion. Small thruster burns adjust the trajectory, plotting an intercept course with the target asteroid. You float in the cramped crew compartment, held in place by a loose harness that prevents you from bouncing against the walls during thrust maneuvers. Through the small viewport, you watch the platform recede, its solar panels catching the distant sunlight like the wings of some mechanical insect. The 38-minute transit passes in a peculiar, timeless state. Everyone has retreated into their own heads, running through the day's procedures, checking equipment, or simply existing in that meditative state that develops during long-duration missions. Conversation would require effort, and nobody has energy to spare. The silence is broken only by the occasional hiss of thrusters adjusting course and the constant background whisper of the life support system. Asteroid 2043KX grows slowly from a point of light to a recognizable rocky body, rotating lazily in its endless orbit. The asteroid is roughly oval, about 200 meters at its longest axis, tumbling through space with the irregular motion of an object with no preferred orientation. Its surface is heavily cratered, pockmarked by countless impacts over billions of years. Some craters are fresh, showing bright material where space weathering hasn't yet darkened the exposed rock. Others are ancient, their rims worn smooth by eons of micrometeorite bombardment. The composition is immediately visible even from a distance. Dark carbonaceous material dominates the surface, giving the asteroid a charcoal-like appearance. This is what classifies it as a C-type asteroid, the most common variety in the outer belt. These bodies formed from the primitive materials of the early solar system, aggregating from the solar nebula before the sun ignited and blew away the lighter elements. They're essentially time capsules, preserving the chemical composition of the disk of gas and dust that collapsed to form our star and its family of planets. C-type asteroids are prize targets for miners because they contain significant amounts of water, locked into the crystal structure of hydrated minerals or frozen as ice in permanently shadowed craters. They also contain organic compounds, carbon-rich molecules that include simple hydrocarbons. These aren't fossils of ancient life, but rather the chemical precursors that made life possible when similar materials rained down on young Earth 4 billion years ago. The carbon itself has value. It can be processed into structural materials, shielding, even food-grade proteins with the right processing. The shuttle's radar maps the asteroid's surface, comparing the topography against previous scans to identify any changes. Asteroids aren't static objects. They shed material constantly, tiny fragments ejected by thermal stress or micrometeorite impacts. The rotation changes over time as outgassing provides tiny thrust, or as impacts alter the mass distribution. What was a safe landing site last week might be covered in fresh debris today. Marcus identifies the optimal approach vector, a point on the asteroid's surface that's been prepared during previous visits. Anchor points are already drilled into the rock, providing attachment points for the work equipment. The shuttle approaches cautiously, rotating to match the asteroid's spin. This is delicate work. Approach too fast and you risk collision. Too slow and you waste propellant on multiple correction burns. Marcus has done this hundreds of times, and his hands move across the controls with the unconscious grace of expertise. The shuttle's grappler arms extend, reaching for the anchor points. Magnetic clamps engage with solid thunks that reverberate through the hull. The shuttle is now physically coupled to the asteroid, rotating with it through space. Your inner ear protests the change in motion, insisting that you should feel something, some sense of rotation, but there's only the slight pressure of the harness and the gentle tug of your boot's magnets against the deck. Time to work. You cycle through the airlock with Elena Vasquez, the geologist, while the others remain in the shuttle preparing equipment. The airlock opens directly onto the asteroid's surface, or rather, onto a prepared work platform bolted to the rock. The platform is minimal, a metal framework with tool racks, sample storage compartments, and safety tethers. Everything is secured against the asteroid's minimal gravity, which is so weak that a strong jump would send you drifting away into interplanetary space. You clip your safety tether to the platform, a redundant precaution that makes the difference between working and becoming a tiny moon of this asteroid, orbiting helplessly until your life support runs out. The tether is rated for forces far beyond what the asteroid's gravity could generate, and it's attached to your suit at multiple hard points. Even if you somehow manage to achieve escape velocity, the tether would yank you back to safety. Probably, hopefully. The mining operation begins with assessment. Elena deploys her portable spectrometer, a device that bombards the asteroid's surface with X-rays and analyzes the emitted radiation spectrum. Every element emits characteristic wavelengths, creating a chemical fingerprint. She's looking for concentrations of water-bearing minerals, the hydrated silicates that comprise up to 20% of some C-type asteroid's mass. Where water concentrations are highest, that's where you'll drill. The initial readings are promising. The spectrometer indicates significant water content in the first meter of regolith, the loose rocky material covering the asteroid's surface. Deeper might be even richer deposits, ice that survived billions of years in the permanent cold of this spinning rock. The question is whether the concentration justifies the energy cost of extraction. Every operation gets weighed against the brutal economics of space mining. Time is propellant. Propellant is money. Money is the difference between this operation continuing or becoming another abandoned platform in the growing graveyard of failed mining ventures. You unpack the drilling rig, a specialized piece of equipment that took a decade to develop and cost more than a small Earth nation's annual budget. It looks deceptively simple: a motor unit, a drill shaft, and a collection system. But the engineering is extraordinary. The drill has to function in extreme cold, in vacuum, with no atmosphere to cool the motor or carry away the heat generated by friction. The collection system has to capture the pulverized rock without letting it drift away in microgravity. And everything has to be light enough to justify the launch cost, while robust enough to survive the vibration and stress of drilling through primordial rock. You anchor the drill using explosive bolts that punch into the asteroid's surface, providing temporary but solid attachment points. The setup process takes 20 minutes, every movement careful and deliberate. Drop a component out here and it's gone, drifting away at escape velocity, lost forever in the vastness between Mars and Jupiter. You triple-check every connection, every seal, every lock that holds the drill assembly together. The drilling begins with a high-pitched vibration you feel through your boots and the mag locks holding you to the platform. The drill bit, tipped with industrial diamond, bites into carbonaceous rock that's been sitting unchanged for 4.5 billion years. You're cutting into material that predates Earth's moon, predates the formation of Earth itself, pristine samples of the solar system's birth preserved by the cold and darkness of space, dust plumes from the drill site, but not like dust behaves on Earth. In the asteroid's near-zero gravity and complete vacuum, the pulverized rock sprays outward in perfectly straight lines, each particle following its own ballistic trajectory. The collection shroud around the drill captures most of it, sucking the particles into a holding tank where they'll be analyzed later. But some escapes, creating a temporary cloud of ejecta that glitters in the sunlight like metallic snow. The drill penetrates deeper, and the real treasure begins to reveal itself. The collected material, fed through the preliminary analysis system, shows increasing water content with depth. At 1 meter down, the regolith is 15% water by mass. At 2 meters, 20%. At 3 meters, the drill encounters a pocket of nearly pure water ice, sublimating slowly into vacuum but mostly preserved by the overlying layers of insulating rock. This is what justifies the entire operation. Water in space is worth exponentially more than water on Earth, not because it's rare, but because it's expensive to transport. Every kilogram of water lifted from Earth's surface to orbit costs thousands of dollars in launch fuel. But water extracted from asteroids is already in space, requiring no energy to escape a gravity well. It can be broken down through electrolysis into hydrogen and oxygen, providing both propellant and breathable air for habitats. It can be used as radiation shielding, as drinking water, even as raw material for growing food. You switch the drill to extraction mode, where it begins pulling up the ice-rich regolith and feeding it into the processing unit. This is a miniature version of the larger refinery back on Platform 7, but it can perform the basic separation of water from rock. The collected material gets heated gradually, allowing the water to sublimate and be captured in cold traps. The remaining dry rock, now worthless, gets expelled back onto the asteroid's surface. It drifts down in slow motion, taking minutes to finally settle under the minimal gravity. The extraction process is meditative in its repetition. Drill, collect, process, extract, repeat. Hours pass in a rhythm broken only by equipment maintenance and the occasional need to reposition the drill for a new site. Your suit's life support system keeps you alive, recycling your air, regulating your temperature, monitoring your vital signs. Every 20 minutes, you stop to drink from the water tube inside your helmet, carefully ration sips from your personal supply. Dehydration is dangerous in a pressure suit, where your body loses moisture through respiration but has no way to sense thirst normally. The sun creeps across the sky, which is really just your perspective of the asteroid rotating beneath it. The shadows shift and lengthen, changing the temperature differentials across the asteroid's surface. In direct sunlight, the rock warms to almost comfortable temperatures, approaching 40 degrees Fahrenheit. In shadow, it plunges to more than 200 degrees below zero. You work at the boundary between light and dark, where the extreme temperature shifts create thermal stress fractures in the rock. 6 hours into the shift, you've extracted approximately 200 kilograms of water, now frozen in storage tanks ready for transport back to Platform 7. That represents thousands of liters of propellant when broken down into hydrogen and oxygen, enough to power several shuttle trips or provide life support for the habitat for weeks. The value calculation plays out in your head automatically. 200 kilograms at current market rates for space-delivered water, minus the propellant cost of this mission, minus the equipment depreciation, minus the crew salaries and life support costs. The margins are razor thin, dependent on maintaining efficiency and avoiding equipment failures. The break comes at hour 7, mandated by safety regulations that recognize human limits even when the work remains unfinished. You maglock to the work platform and open your suit's food port, a small chamber that allows you to eat without depressurizing the entire suit. The meal is a protein paste tube, engineered nutrition that tastes vaguely like chicken if you don't think about it too much. You squeeze it into your mouth, chew the unnaturally smooth texture, and swallow. Calories absorbed, energy restored, ready for the remaining hours. This is when the isolation hits hardest, during the brief pause when you're not occupied by immediate tasks. You're sitting on a rock spinning through space 300 million miles from Earth, surrounded by vacuum that would kill you in seconds, kept alive by a suit that's a series of potential failure points. The nearest human is 40 meters away in the shuttle. The nearest hospital is 8 months distant by the fastest available spacecraft. You are profoundly, existentially alone in a way that humans weren't designed to experience. The communication comes through during your break, a recorded message from Earth transmitted during the last communication window. Your daughter's voice, time-shifted by 22 minutes and compressed for efficient transmission, fills your helmet. She tells you about her school project on space exploration, how she told her class about her parent who mines asteroids. Her enthusiasm is unfiltered, childlike, unshadowed by the understanding that you won't see her for another 8 months. She ends with, "I love you," and that phrase spans 300 million miles to hit you harder than any micrometeorite impact. You record a response, keeping your voice steady, describing the asteroid in terms she might understand. It's like a flying mountain, honey, tumbling through space since before dinosaurs lived on Earth. I'm collecting water from this mountain, water that will help other people live in space someday. You don't mention the radiation exposure that accumulates with every day outside Earth's protective magnetic field. You don't mention the nightmares about suit failures or the constant low-grade fear that something will go wrong too far from help. You end with, "I love you too," and schedule the message for the next transmission window. The afternoon shift continues with sample collection for analysis back on Platform 7. Elena Vasquez uses a core drill to extract cylindrical samples of the asteroid's interior, preserving the layered structure. These cores will be examined under microscopes and electron beams, analyzed for mineral composition, organic compounds, and structural characteristics. Every asteroid tells a story about the solar system's formation, about the chemical processes that occurred in the solar nebula, about the collisions and interactions that shape the planets we know. The samples get carefully sealed in aluminum containers, protected from contamination and thermal stress. They'll be cataloged, numbered, documented with precise coordinates of their extraction location. This is science as much as mining, and every core sample contributes to humanity's understanding of our cosmic origins. Some of these samples will eventually make their way to Earth, shipped back on supply shuttles, destined for research laboratories where scientists will study them with tools too delicate and power-hungry to bring to the asteroid belt. The mining equipment begins showing signs of strain as the shift extends past 8 hours. A motor bearing in the drill overheats, requiring shutdown and replacement. The backup motor gets swapped in, a process that takes 45 minutes of careful work with limited dexterity and pressure suit gloves. Every maintenance task is exponentially more complex in vacuum, where you can't use standard lubricants or assume thermal expansion behaves normally. The replacement motor comes from the shuttle's spare parts inventory, reducing the available backups by 1, adding to the mental calculation of risk versus reward. Hour 9 brings a close call that's almost routine in its development but terrifying in its potential. You're repositioning the drill when your safety tether snags on a jagged rock outcropping. The tether holds, designed for exactly this scenario, but the sudden jerk sends you spinning slowly away from the work platform. For 3 heartbeats, you're untethered mentally if not physically, watching the asteroid's surface rotate past your faceplate, the stars wheeling overhead, the void opening beneath you. Then training kicks in, and you engage your maneuvering pack, small bursts of nitrogen that halt your rotation and pull you back to the platform. The incident gets logged in your suit's computer, adding to the statistical database of near misses and minor accidents that inform future safety protocols. Your heart rate, which spiked to 140 beats per minute, gradually settles back to the low 60s that's normal for you. The suit's medical monitoring system flags the event, but determines no immediate intervention is needed. Later, during the psychological debrief, you'll describe the incident in calm, measured tones, assuring the reviewing physician that it was routine, controlled, nothing to worry about. You won't mention how for those 3 heartbeats you could feel the void pulling at you, inviting you to drift away into the endless dark. The final hours of the shift pass in exhausted determination. Your muscles ache from the constant small corrections needed to maintain position in microgravity. Your hands hurt from gripping tools through the stiff resistance of pressurized gloves. Your back complains about the posture required to work hunched over the drill assembly. The suit's life support system is functioning perfectly, keeping you alive, but you're viscerally aware of every little discomfort that the system can't address. The extraction total for the day reaches 280 kilograms of water ice, exceeding the target by 15%. This is good news that will appear as a green number on some spreadsheet back on Earth, a small victory in the endless battle to make space mining economically viable. Each kilogram represents potential propellant, breathable oxygen, drinking water, radiation shielding. Each kilogram justifies the massive investment that put Platform 7 in operation and keeps it staffed with 12 humans living on the edge of survivability. The shutdown procedure for the mining equipment is as methodical as the startup was. Systems get powered down in sequence, preventing thermal shock that could damage components. The drill bit, worn after a full shift of cutting through ancient rock, gets retracted and inspected. It shows the expected wear patterns, microscopic chips, and dulling that will require replacement after 3 more shifts. The collection system gets purged, ensuring no residual material is left to freeze solid and damage seals or valves. The collected water ice, now stored in insulated tanks, gets loaded onto the shuttle for transport back to Platform 7. 280 kilograms doesn't sound like much, but in microgravity, moving that mass requires careful planning. The tanks have to be secured against the shuttle's thrust acceleration and deceleration. They have to be thermally isolated to prevent sublimation during the 38-minute transit. Every restraint gets checked twice, every seal verified, every securing clamp confirmed locked. You help Elena pack up the sample cores, each one carefully labeled and documented. These fragments of ancient rock have crossed billions of years to reach this moment, preserved in the cold death of space, now destined for analysis by scientists who will tease out their secrets. The samples represent something more than economic value. They're pieces of history, evidence about how our solar system formed, clues about the materials that eventually aggregated into the planet you were born on. The final task before departing is securing the worksite. This asteroid will be visited again, possibly tomorrow, certainly within the week. The drill platform gets locked down, tools secured in their racks, safety barriers erected around the excavation site. Everything must survive the temperature extremes and occasional micrometeorite impacts that are constant hazards in the belt. Nothing can be left loose to drift away or become a hazard for future operations. The transit back to Platform 7 feels longer than the outbound journey, though it takes the same 38 minutes. Exhaustion settles over the crew compartment like a physical presence. Everyone retreats into their own heads, running on the last reserves of energy, anticipating the moment when the suit can come off and they can float in the relative comfort of the habitat's shirt-sleeve environment. The platform grows from a distant point to a recognizable structure, solar panels catching the sunlight, radio antennae bristling from the communications module, the various cylindrical sections that house 12 humans in this outpost of civilization. It's small, fragile, completely inadequate to the task of making space hospitable for human life. But it's home, at least for the next 6 months until your rotation ends and someone else takes your place on the extraction crew. The shuttle docks with mechanical precision, grappler arms engaging the docking collar, seals mating with practiced ease. The connecting tunnel pressurizes, and the indicator light shifts from red to green. You cycle through into the habitat and entering the equipment bay where Yuki Tanaka waits to help with suit removal. The 20-minute process of suiting up is reversed, each seal broken, each connection verified as you're extracted from the shell that kept you alive. The first breath of habitat air after 12 hours in the suit always tastes strange, too rich, too complex after the sterile processed oxygen mix. The temperature feels wrong, too warm after the neutral precision of the suit's thermal control. Your body has to readjust, relearn what normal sensation feels like, remember what it's like to exist without layers of protective material between you and the environment. The suit gets hung in its dedicated rack, connected to power for recharging batteries and computers, to life support for refilling oxygen tanks and replacing scrubber materials. Yuki inspects every seal and joint, documenting wear and damage, scheduling maintenance and replacement as needed. The suit is worth more than most Earth houses, and keeping it functional is what stands between the crew and sudden death. The decontamination shower is brief but necessary, washing away the asteroid dust that clings to everything despite the suit's seals. The water, recycled and carefully rationed, washes away the physical residue of the day's work. What it can't wash away is the accumulated fatigue, the stress that lives in your muscles and bones, the knowledge that tomorrow you'll do this all again. Exercise is mandatory, a 2-hour block that can't be skipped without medical approval. The low gravity of Platform 7, that 0.3 Earth standard, isn't enough to maintain bone density and muscle mass. Without regular resistance training, your body would begin the slow process of adapting to microgravity, becoming weaker, less capable of handling the physical demands of mining work. The treadmill and resistance machine are your enemies and your salvation, instruments of torture that keep you functional. You strap into the resistance machine, basically a sophisticated arrangement of vacuum cylinders that provide adjustable force across the full range of motion. The workout is programmed by medical personnel back on Earth, adjusted based on your daily biometric data, calculated to provide optimal stimulus for bone and muscle maintenance. It's exhausting, painful, and absolutely necessary. You push and pull against the mechanical resistance, feeling your muscles burn, your heart rate climb, your lungs work to process the increased oxygen demand. The treadmill is worse because it's boring. You strap your feet to the moving belt and run in place for 45 minutes, watching entertainment media on a screen mounted to the wall. The media library contains thousands of hours of content, carefully curated for psychological benefit. Nothing too violent, nothing too depressing, just an endless stream of comedies and dramas and documentaries that provide temporary escape from the reality of living in a metal tube 300 million miles from home. Dinner is a social event by necessity and design. All 12 crew members gather in the galley module, floating around the table, sharing the day's experiences. The meal itself is nothing special. Protein portions that might be chicken, or might be fish, or might be neither, engineered to provide optimal nutrition with minimal waste. Carbohydrate portions that taste vaguely like rice. Vitamin-supplemented vegetable portions from the hydroponics bay. Fresh lettuce that's worth more than gold by the time you factor in the cost of maintaining the growing systems. The conversation flows in patterns established over months of confinement. Marcus talks about a navigation problem he solved during the day's shuttle operations. Elena describes the sample cores in enthusiastic detail, her passion for geology undimmed by months of examining similar rocks. The platform commander, Adrian Wolf, discusses tomorrow's operational targets and the supply shuttle that's due to arrive in 3 days with fresh food, mail from Earth, and replacement parts for critical systems. You contribute your own stories, editing out the close call with the tether, focusing on the good extraction numbers and the interesting mineral deposits Elena identified. No one mentions the isolation, the homesickness, the constant low-grade fear that something will fail catastrophically. These things are understood, acknowledged through silence rather than discussion. Talking about them won't change anything and might weaken the collective psychological resilience that keeps everyone functional. The meal ends with the ritual of waste disposal and cleanup. everyone contributing to the basic housekeeping that keeps the habitat livable. In microgravity, even simple tasks require coordination and attention. Food particles float if not captured. Water droplets drift until they encounter a surface. Keeping the living space clean is constant work that never quite succeeds, but can't be abandoned. You spend the evening hours in the recreation module, a small space equipped with exercise equipment, entertainment screens, and a cupola window that provides an unobstructed view of the surrounding asteroid field. The window is small, expensive to install and maintain because it represents a potential leak point in the habitat's pressure envelope. But the psychological benefit justifies the risk, being able to see out, to have visual confirmation that space exists beyond the metal walls, helps prevent the kind of sensory deprivation that can lead to hallucinations and psychological breakdown. You float near the window, locking your feet to the floor for stability, and stare out at the universe. The asteroid belt stretches in every direction, though belt is a misnomer that gives the wrong impression. The asteroids aren't densely packed, they're scattered across millions of cubic miles, each one pursuing its own elliptical orbit around the distant sun. From your viewpoint, you can see perhaps a dozen asteroids clearly, points of reflected light against the absolute dark, each one a potential mining target or a hazard to navigation. The stars are different here than they were from Earth. Without atmosphere to scatter and dim them, they're pinpoint sharp, countless millions more visible than you ever saw from the ground. The familiar constellations are distorted by your new viewing angle, patterns disrupted by the 150 million miles you've traveled from home. The Milky Way is a river of light across the sky, our galaxy seen from the inside, a band of countless stars too far away to resolve individually but collectively bright enough to cast faint shadows. Earth is visible if you know exactly where to look and have faith that your eyes can distinguish it from the surrounding stars. It's a pale blue dot, smaller than most stars in apparent size, distinguished only by its steady light that doesn't twinkle in the non-existent atmosphere. That tiny dot contains 8 billion humans, every person you've ever known except for the 11 others currently aboard Platform 7. Your daughter is down there, looking up at the night sky, perhaps wondering which point of light is her parent. The video call is scheduled for 2100 hours, timed to coincide with your daughter's morning and your evening. The communication system has limited bandwidth and significant delay, making real conversation impossible. Instead, you speak into the camera, describing your day in terms she might understand, careful to make it sound routine and safe. You tell her about the asteroid you worked on today, how it's been spinning through space since before dinosaurs lived on Earth. The delay is 22 minutes now, slightly longer than it was this morning because Earth and the asteroid belt are currently moving apart in their respective orbits. In 22 minutes, your daughter will receive your message. In 44 minutes, you'll receive her response. The conversation is conducted in discontinuous bursts, separated by eternity. Each message carefully composed because spontaneity died about 100 million miles ago. Her response arrives during your bedtime routine, her voice cheerful and enthusiastic, telling you about her day at school, about the math test she thinks she passed, about the cat that's been visiting the backyard. She's adapted to your absence with the resilience of children, incorporating your rare video calls into her normal life as easily as she incorporated the morning routine or homework schedule. She ends with, "I love you," and you wonder if she understands how those 3 words sustain you through the isolation and fear. The sleeping quarters feel different each night, sometimes claustrophobic, sometimes oddly comforting, always inadequate to the basic human need for space and privacy. You zip yourself into the sleeping bag, floating in the weak 0.3 gravity, listening to the habitat's constant mechanical song. The ventilation system whispers, the water reclamation gurgles. Somewhere in another module, someone's laugh echoes through the connected corridors. These sounds are proof that you're not alone, that other humans share this metal shell spinning through the void. Sleep comes slowly, resisted by a brain that hasn't quite processed the day's experiences. You lie in the darkness, watching the green emergency lights paint shadows on the curved walls, feeling the barely perceptible spin that provides the weak gravity. Your body aches with the specific exhaustion of physical labor in a pressure suit. Your mind wrestles with thoughts that can't be completely suppressed. The close call with the tether, the 22-minute delay in communications with Earth, the 8 months remaining in your rotation. The psychological assessment you completed before this mission identified you as resilient, adaptable, capable of handling isolation and stress. The assessment didn't predict how accumulating days of separation would feel, how each morning would require a conscious decision to continue, rather than just floating in your sleep bag until life support runs out. No assessment can capture the experience of being 300 million miles from everything that makes life feel meaningful. But you'll wake tomorrow when the alarm sounds. You'll go through the morning routine, eat the engineered breakfast, suit up, and travel to another asteroid to extract more water that will become more propellant that will enable more mining operations. The work has its own momentum, a logic that exists independent of your feelings about it. The water needs to be extracted, the quota needs to be met. The economic calculations need to balance, or Platform 7 becomes another abandoned artifact of humanity's fumbling attempts to industrialize space. Maybe that's enough. Maybe purpose doesn't need to be profound, just present. Maybe meaning is found in the small victories. 280 kilograms of water ice extracted, a sample core that tells Elena something new about the early solar system. A video call with your daughter that bridges 300 million miles of absolute emptiness. Maybe the accumulated weight of ordinary days, repeated across months and missions, adds up to something that justifies the isolation and fear. The universe doesn't care, of course. The asteroid belt will continue its eternal orbit whether humans mine it or not. The sun will shine on these ancient rocks for billions of years after the last human has died, after Earth itself has been consumed by the red giant phase of solar expansion. Against that cosmic indifference, your daily work extracting water from carbonaceous asteroids is laughably insignificant. But significance is a human concept, dependent on human perspective, and from that perspective, the work matters because you've decided it matters. The darkness deepens as your consciousness slides toward sleep. The habitat sounds become background noise, white static that masks the silence of space beyond the walls. Your breathing slows, synchronizing with the ventilation system's rhythm. Your muscles finally release the tension accumulated through 12 hours of work, letting go of the constant vigilance required to stay alive in a hostile environment. Tomorrow is still 9 hours away, time enough for your body to process the day's stress and prepare for the next one. Tomorrow will bring new asteroids to mine, new samples to collect, new water ice to extract and process into the fuel that keeps this entire operation viable. Tomorrow will be the same as today, which was the same as yesterday, in the endless repetition that characterizes long-duration space operations. But tonight, in the small mercy of sleep, you can let go of consciousness and drift in the darkness behind your eyelids. A different darkness than the void outside, this one familiar and comforting. A space where Earth feels closer, and your daughter's voice doesn't need 22 minutes to reach you. The habitat spins on through the asteroid belt, one small point of human warmth in the cold mathematics of interplanetary space. Inside its metal walls, 12 people sleep and dream of home, or of purpose, or of paychecks large enough to justify months of isolation. The life support systems continue their tireless work, recycling air and water, providing the minimal requirements for human survival. The solar panels track the distant sun, converting light to electricity with patient efficiency. And out beyond the platform, scattered across millions of cubic miles, countless asteroids pursue their endless orbits, waiting for human hands and machines to claim their resources, to convert ancient rock into fuel and metal and water, to feed humanity's inexorable expansion away from the cradle of Earth. Before you fully let go into sleep, you allow yourself one small acknowledgement of the absurdity. You're a miner. Your ancestors might have worked coal seams deep in Earth's crust or panned for gold in river streams. They would understand the basic act of extraction, of finding value in raw material. But they could never have imagined this. Working in a pressure suit on a rock spinning through space 300 million miles from home, extracting water ice old as the solar system itself, sustained by recycled air and engineered food, and the questionable proposition that human beings belong anywhere but the planet that made them. The absurdity is too large to process, so you set it aside with all the other impossible facts of your current life. Tomorrow, the alarm will sound. Tomorrow, you'll work another shift. Tomorrow will be ordinary in ways that would have seemed impossible just a few generations ago. And that, somehow, is enough to let sleep finally come, pulling you down into darkness where dreams wait, dreams of Earth and family and a gravity that doesn't need to be artificially generated. The last conscious thought before sleep claims you. Only 8 months remaining. Only 240 more days until the rotation ends and you can board a shuttle bound for home, begin the long journey back to Earth, to weather that feels random instead of controlled, to a horizon that curves away instead of staying flat forever, to your daughter who's growing up in your absence but who will run to meet you when you finally return. 8 months. You can survive 8 more months. You've survived 3 already. The arithmetic is simple even if the experience isn't. And when this rotation ends and you're safely back on Earth, breathing unrecycled air under an unfiltered sun, you'll have stories to tell, experiences to share, and a bank account that reflects the premium paid for work this dangerous and remote. Whether those things justify the cost, the isolation, the fear, the month stolen from your daughter's childhood, that's a question you don't examine too closely. Not here, not now, floating in the darkness with sleep approaching. Some questions are too large, too sharp, too capable of cutting through the rationalizations that make this life bearable. So you let them go, release them into the void where they belong, and surrender to the sleep that every body needs, that every mind craves, the small death and renewal that makes tomorrow possible. Good night from the asteroid belt, from this small spinning habitat 300 million miles from home, from 12 humans who've traded comfort for purpose and proximity for perspective. May your dreams be gentle, and may tomorrow's challenges find you rested and resilient. And if you're watching this from Earth, from the warm embrace of gravity and atmosphere and everything that makes life feel natural, remember, somewhere out in the dark, people are working to build the future, one extracted kilogram at a time. Before you go, if you enjoyed this journey into the life of an asteroid miner, take a moment to like this video and subscribe to see more glimpses into historical lives and future possibilities. Drop a comment about what you'd like to see next. Until then, rest well, wherever you are, and be grateful for the small mercies, breathable air, comfortable gravity, and the presence of the people you love. The habitat lights dim to their nighttime setting. The universe continues its patient rotation. And somewhere between sleep and waking, you drift through the darkness, mining dreams from the same infinite void that surrounds the platform, extracting meaning from the raw material of experience, processing it all into the fuel that powers another day, another shift, another step into the future that humans are building, one asteroid at a time. Good night.